Hi, this is Mr. Roberts at Shasta High. I'm going to go through a couple of the questions types that you're likely to see on the Chapter 9 test. I recommend that you pause the video, try the problem yourself, and then you can look at my solution and compare the two. So if you want to, go ahead and pause now. So let's take a look at the solution here. When you're finding the area of a triangle, right, areas are found by multiplying bases and heights, and they must be perpendicular to each other. If this is a base or a height, this would not be the corresponding base or height, right? So I need to figure out the length of this, and then from that I can compute the area. So in a right triangle, of course, we know by the Pythagorean theorem that a leg squared plus the other leg squared, I'll do b squared, is equal to the length of the hypotenuse squared, c squared. So I can use this to figure out the value of b. B squared then would be 17 squared minus 8 squared. And I'm going to take the square root of both sides of this, and of course we're only going to be looking at the principal or positive root because we're talking about the length, minus an 8 squared, the length of a side of a triangle. So I'm looking at the square root of 17 squared minus 8 squared. And according to my calculations, b should equal 15. Now that I know b is 15, I can apply the formula for the area of a triangle is equal to 1/2 times the base times the height. And when I multiply that, well, of course, I'm looking at 4 times 15, which is 60. So the area of this particular triangle is 60, and my units are square centimeters. Find the area of the parallelogram. In this problem, I have a very nice base, and you can see that the base, or an extension of the base, has this segment right here, which is clearly the height or altitude of this parallelogram. So it's just a matter of multiplying 22 times 12. And we get an area of 264. So the area is 264. And again, since it's an area and I'm multiplying centimeters times centimeters, it is 264 centimeters squared. Find the area of a rhombus. Let's see. Well, let's think about what we know about a rhombus. If I was to draw the other diagonal, we know that the diagonals, oops, that's not quite right. The diagonals of a rhombus are perpendicular. And the diagonals of a rhombus do bisect each other. So if I had drawn this better, it might be a little bit more self-evident. But this diagonal is being bisected by the one that I drew. So these would each be 9. And from that, I could use this 15, because I see a right triangle in here where here's a leg that I don't know. One of the legs is 9 and the hypotenuse is 15. So I could use that to figure out the length of this other hypotenuse. I'm going to call this A in this case. And then we have a formula that tells us that the area of a rhombus is equal to 1/2 times the product of the diagonals. So I could do diagonal 1 times diagonal 2. But also, you know, I could just find the area of these triangles, and actually they'll all be congruent triangles. Find the area of the congruent triangles and find the area of one of them and multiply by 4. I'm going to go ahead and use this formula though, and I do need to figure out a. So I'm going to go a squared plus the other leg squared, which was a 9. That's unfortunate, but my a and 9 look similar, and that equals 15 squared. So a squared is going to equal 15 squared minus 9 squared. And then a, again, we're just looking at the principal root. This equation does have two solutions, the plus or minus, but we're just looking at the positive one because we're in a geometric setting, 15 squared minus 9 squared. And when I evaluate that, it appears that there's a multiple of a Pythagorean triple here because a is equal to 12. Now, if a is equal to 12, this other diagonal then has to be equal to 24. So my two diagonals are, one of them, the one that I could originally see in the problem, was 18, and the other diagonal is equal to 24. So it looks like the product of 18 and 24 divided by 2 is equal to 216. So the area of this rhombus equals 216. And again, since I'm multiplying centimeters times centimeters, each diagonal was expressed in centimeters, I get an area of 216 centimeters squared, square centimeters. Next, find the area of a kite. Let's see. Well, I know that one of the diagonals in a kite is indeed bisected. This one is not bisected, but this one is bisected. So I do know that this is 8 centimeters. And that's going to allow me to find this bit of this diagonal. I do know the rest of it's 15. And the kite, we can use the exact same formula to find the area using the product of the diagonals, 1/2 the product of the diagonals. Or again, you know, I could find the area of this triangle and this triangle. They'll be congruent to each other by side, angle, side, and I can find the area of this triangle and just add them up. Also, remember that the diagonals of a kite are always perpendicular. So when that tells me this is a kite, that means I can go ahead and proceed and use the Pythagorean theorem here. So let's find our x. X squared plus 8 squared is equal to 10 squared. So we have that x is going to equal the square root of, and let's just go ahead and do this, 100 minus 8 squared is 64. And of course that is 36. So x will equal the square root of 36, which is 6. And again, in this step of the equation, we're only picking up the positive root because it's a geometric problem. Mr. Roberts, you have to keep saying that. So this is 6, and down here we have 15. So this total diagonal, if I add the 6 and 15 up, I will carry the 1, I have a diagonal of 21. So my two diagonals are 8 and 8, 16, and the other one is 21. So my area, using the formula that relates area and the two diagonals, is, again, it's diagonal 1 times diagonal 2. So the area is going to equal 1/2 times 16 times 21. And when I look at half the product of 16 and 21, whoops, I get what I believe is 168. And again, we're still in centimeters. So, oops, I'm sorry, so these are centimeters squared. Find the radius of circle P in which the circumference is 36 pi centimeters. Well, there's two ways of looking at the circumference, right? The circumference is equal to either the diameter times pi, or circumference is equal to, we customarily write it as 2 pi r. Of course, we're noticing that in this we have a 2 and an r, and 2 times the radius is the diameter. So you can see they're saying the exact same thing. And also, you know, on the day before Pi Day, the day that I'm recording this, remember our definition of pi. Pi is the ratio of a circle's circumference to its diameter. So if you're out in the wild and you see a triangle, or a circle rather, you might want to measure around it and divide by its diameter, and you're going to find it's about 3 each time you do it, especially with crude measurement devices. The better your measurement devices are, the better you'll do. So anyways, I know that the circumference, C, is, I'm going to be using this relationship here. The circumference is 36 pi, and I know that the circumference is equal to 2 pi r, so I'll write 2 pi r. And I'm just asked to figure out what the radius is. Since this is the variable I'm solving for, I'm going to divide both sides by 2 pi. And my pi divided by pi, of course, is just 1. And 36 divided by 2 is equal to 18. So I know that the radius is equal to 18, and the units would also be centimeters. Given that the circle is inscribed in the square, find the area of the circle to the nearest hundredth. It looks a little distorted on my screen, and perhaps it will on YouTube as well. But if this is a square, right? I know that all 4 of these sides are 16 units long, and half of those would be well, the half of 16. Whoops. And the reason why that matters, of course, is because that'll be the length of my radius. So I have a circle here with a radius of 8, and again, it's also centimeters, 8 centimeters. And I'm asked to find the area of it. It does say find the area. The area of a circle is equal to pi times the radius squared. And if my radius is 8, the area will equal pi times 8 squared. And pi squared, not pi to the 6th. And 8 squared is 64, so you could write the area as 64 pi if you wanted to express it in terms of pi, but this says write your answer to the nearest hundredth. So I'm going to grab my scientific calculator and multiply 64 times pi. And I get to the nearest hundredth. You should round this to 201.06. The next digits are 19. So this would round to 6. And again, since this is an area and my dimensions were expressed in centimeters, this will be square centimeters.